Hello guys, good evening. This is Edgar from Powertone Audio Services, and tonight we're having this mono amp. The brand is STETSOM. It's a Brazilian made amp, and it's really popular here in the UAE because of its output power on a small package. The model is EX3000EQ, and it is rated 3000 watt RMS with 1 ohm load. This amplifier was sent to me 3 days back, and the customer told me that it was damaging his subwoofers. He told me that he had 3 burned subwoofers already. And you know guys, I believe with this kind of problem there is a DC voltage coming out from the output terminals of the speaker. Normally speakers only receive AC voltage, but if you fed speakers with a significant amount of DC, then it will work after some time, but eventually it will fail, and worst of it will burn your speakers. So it is really frustrating. Check natin if really there is a DC voltage output or any fault or any damage inside the amplifier. Tara, umpisa na natin. It seems it's well and good. I don't see any broken part or any burned area on this amp, on the board. This amp is driven by, on the amplifier side, with these 2 chips. This is the amplifier chips, and I believe this is the IRS 20957S, and then these 2. Each chip is driving 2 MOSFET, one on the low side and the high side, and the other one is this one, driving these 2 MOSFET also on the high side and the low side. This area, I believe, is the supply area. This is the 4 MOSFETs, and with the 2 diodes that rectifies the rail voltage for the amplifier section. And this area, this part is the preamp section. These are the op amps that receives the signal on the RCA input. After that, it will be amplified by these 2 chips, giving signal to the gate of these 4 MOSFETs, each on these chips, on these amplifier chips, and then the output is filtered with this LC circuit. This LC circuit eliminates the high frequency, so it will only put out the low frequency on the terminals. Now, if there are normally, if there on the low side, you should not get any DC output on the drain, leg of this low, and on the high you should not get any DC voltage on the source, each of these amplifiers. So that will be the first thing we will check. Now let's fire this up. Lagyan na natin ng supply and we will see if we get we will see any DC voltage from the terminals of these MOSFETs. Now I connected the power supply. Okay, so let's turn this on and we will try to we will measure the voltage in the speaker terminals. We will see there's a DC voltage output. Now the DC output is minimal, but the issue is it is gradually increasing. As you can see guys, tumataas yung DC voltage niya sa output, and once it will reach maybe around 1 volt DC, and it is not good. See, you can see it's gradually increasing. Normally you should get around 5 or to 6 milliamperes on this output. Okay, let us check the terminals of the MOSFETs. So I will place my probe in the negative out, and on the low terminal, on the low MOSFET terminal source, drain, there should be no DC. But there is a DC. Now, on the high side, we will check the source terminal. Yes, the same thing, there is DC. Now on the next channel, we check on the high side source. Yes, this is correct. And on the low side, on the drain leg of the MOSFET, should be 0. Yes, this is 0. So that means these two MOSFETs, I believe, is leaky, causing the DC output of this amplifier. Now what we're gonna do is, let's try to take out this clamp, and this one is a lot easier than the other amplifiers. Ibang ampli, yung clip type na minsan nakakaasar tanggalin. These ones are screwed on the body, which serves as the heatsink, and this is much easier to remove. So let's remove let's turn off first and start removing. Remove and these are the MOSFETs are IRFB 4115. Yes, this is RFB4115. Okay, let me check if I have this part. Sana meron ako. Still lucky. I have 3 left on my spare parts box, and these ones are IRF 4115, yes, with the same buds, of course. No, the other one is not on the same buds. These two are on the same buds. Okay, so what we do now is I will check one thing first. May gusto akong i-check. Let's try to feed a signal on this amp, and we see if the amplifier section is oscillating before we take out the MOSFET. Okay, let me set up my oscilloscope to 5 milliseconds time division and 2 volts per division, and let me set also my signal generator to 2 volts amplitude and 50 Hertz. Now let's connect the RCA input. And then power on. Yes, the amplifier is on. Then let me check with my oscilloscope if there is a signal. Now let me increase the gain. Oh yeah, now we have a signal. That's the clipping point. That means so the only issue, as the customer is telling, is it is blowing up or burning the subwoofers. Madami na raw, 2 subwoofer na raw nasunog niya. Okay, so now what we're gonna do is let me check the low side. This is the low side of this, the amplifier with the defective side. Yep, there's a drive signal on the negative rail. Yes, there's the switching, and on the high rail. Yep, switching. Yep, on the other amp. Yes, switching. Yes, drive signal on the low side of the second, on the other channel. Yep, there's a drive signal, and yes, there's a switching. So I believe there's a leak on this 2 MOSFETs. So what we're gonna do is we'll try to replace these two, and we will see if the DC signal, what I mean, the DC voltage on the terminal will disappear. Subukan natin palitan tong dalawang MOSFET na to, baka sakaling nawala yung DC output. Okay, let's do it. Now I remove the board from the case. This is the two FETs that we're gonna change with these new ones. So let's remove it. Let's put the new one. Let's check if there is any solder bridges. That's good. Good. So no solder bridges. Okay, let me clean this up. Now let's connect the power supply again and fire this up and check there's still a DC voltage on the output. Okay. Let's turn the supply on. Yes, the blue light is on. Now let's check the output terminals. Still DC. There's still DC voltage. Still there is. That means the problem is not on the FETs, on the MOSFETs. So may ibang problema to. In this case, either there is a problem on the drive circuit, or particularly on this chip, this IRS 9275S. But the problem now is I don't have the parts for this at the moment. So the next thing we can do is to order this one, or maybe let me check on my other spare boards. Maybe we can get from a donor board. Okay, give me a second, I'll get back. I got a chip here, the same one, IRS 2975S. So we'll try to replace this chip with this one, and we will see, and we'll check again. I hope we will solve the problem. Let me apply some flux. Okay. Okay, let's apply some, let us reflow and apply some new with new solders. Now we'll put the new one. Let's double check the connections. Okay. Okay, all fine. Now let's check and power it up. But first, let us check the DC voltage output. I hope this will solve the problem. And yes, we have 0.01 volts. Yes, I'm very happy with that. So we have finally solved the problem. So it was caused by this. Actually, it's not a defective one. But maybe there are maybe it's not functioning well already, this chip. So that's it. I'm very happy with this, and let me put back in its case, and we'll try to feed this 50 Hz sine wave, and we'll see the outputs. Let me increase the gain. Yes, we have a signal. So I can conclude that we had a good repair on this board. There's the clipping point. Perfect. Fantastic. So let me put back to the board on its case, and I'll make a bench test to find its to calculate its true power. Now let's proceed with the bench test. Now I connected to my power supply with a 170 ampere power supply, 12 volts, with a 50 Hz input signal and a 4 ohm 400 watt static load resistor. So let's power up. I hope all will go fine. Let's turn my let's turn it on. Yes, the blue light is on. Now let me increase the again to clipping, and then we monitor the voltage, the AC voltage on the output terminal. Once we reach the clipping, and that's the maximum power of the amplifier. So we have around 47.3. Let me note that down. 47.3 volts AC, and we have 54.1 input current DC. So to calculate the power, we use the simple Ohm's law, where power is equal to the voltage squared divided by our 4 ohm static load resistor, which is 4 ohm. So 47.3 squared divided by 4 is 47.2 times 47.2 equals 2004 divided by 4, that is 556.9, around 557 watts at 12 volts. At 14 volts, we have a correction factor of 1.4. That means 557 watts times 1.44. That means 802 watts at 14 volts, 4 ohms. Now if we calculate at 1 ohm, that would be 557 at 1 ohm, that would be 47.2 times 47.2 equals, divided by 1, that would be equals, that would be 2227, approximately 2228 watts at 12 volts. Now for 1 ohm, we have a correction factor of 1.4, so we multiply this with 1.44, and we have 3200 watts at 1 ohm, and the amplifier is rated at 3000 RMS at 1 ohm. So this amplifier is giving its specified watts. Now after this, I will run this with an endurance test for about 30 minutes with a static load of 2 ohms with a resistive load like a subwoofer for around 30 minutes. And if this amplifier passed the test, then we can deliver it to the customer. Thank you again for watching, and see you on my next video and repairs. Thank you.